Greetings everyone. The topic which me and my group are going to present is PCS, Personal Communication Services. PCS was a revolution in communication technology. The figure shown tells us the wide applications of PCS. Thus, PCS forms the integral part of our life, let it be on personal front or professional front. The PCS forms the base for every other technology to flourish. As we can see in the figure, transmission systems, smart buildings, wireless communication services, everywhere PCS has been used and forms the base of that system. The only fact is that we are unaware that technology on which we rely so much is nothing else but PCS. Now, I would like to mention what is the core of PCS, the pillars on which the foundation of PCS was laid. Ubiquitous wireless communication coverage, in which the user has the access to telephone and internet without any constraints of location of user or the location of information which is being accessed. PCS is based on Advanced Intelligent Network, also known as AIN, wherein integration of mobile and fixed networks takes place so as to provide universal access to network and its databases. By virtue of AIN, a user will have a single telephone number for both wireless and wireline services for which the world was awaiting for so long. PCS is originated from architectural model suggested by Ashiti Sheikh Murthy known as ASH93 model. This model has only three layers: information layer, transport layer and access layer. PCS will be characterized by high user densities that will require enhanced network requirements such as common channel signaling and efficient signaling protocols. Why packet switching over circuit switching? That is why PCS requires basically packet switching. As shown in the figure, in circuit switching, there is a dedicated line between the sender and the receiver, whereas in the packet switching, there is no such dedicated lines between the sender and the receiver. Hence, a high density of users can be accommodated in packet switching. Further, packet switching supports wide range of services. Services such as voice, data, email, digital video, and further many more. Hence, commercial grade voice over IP will catapult packet switch PCNs. Large populations of infrequent users, so that economic viability will depend on the ability to effectively share the bandwidth and infrastructural equipments. Packet switching is based on ARQ, that is automatic retransmission query, which gives PCS the ability to compensate for lost or corrupt data through ARQ based transmission strategies. Further, packet switching has high capacity switching, wherein for routing traffic between cells, PCN requires high capacity switching.
Now we will be studying about the architecture of personal communication system. PCS deals with integration of the mobile and the public switch telephony network. Here we can see the radio network and the wireline transport network forming the PCS architecture. Looking at the radio network, there is a mobile station which belongs to the subscriber and is wirelessly connected to the base transceiver station. Each BTS defines a single cell. Many such BTS are connected to the base station controller. The base station controller is connected to the switching center, which is required for switching calls from the PSTN, that is the landline network, to the mobile network and vice versa. Mobility database, which is connected to the switching center, is required for keeping a track of the location of the mobile station. This slide talks about the parameters on which the classification of PCS is made, which will be highlighted in the coming slide. The first parameter talks about the coverage area, which is the geographical area where cellular service is available. It can be larger or smaller. User density. User density is the number of subscribers which can be served by a particular service provider. Quality of service. Quality of service comprises requirements on all the aspects of connections such as the SNR, that is the signal to noise ratio, crosstalk, interruptions, loudness level, etc. Delay. The signal transmitted from a cell site and arriving at a mobile unit will be from different paths, hence time of arrival for each path is different. This eventually induces delay in the system. Taking into consideration previously discussed parameters, we can classify PCS into two types: high-tier communication systems and low-tier communication systems, wherein high-tier is a system that supports base station with large coverage area and low traffic densities but provides low quality of service and high amount of delay. Low-tier communication system is the one which is characterized by small coverage area, high traffic density, high quality of service, low delay and comparatively smaller cells.
High-tier systems. Some of the popular high-tier systems are mentioned over here. First one is AMPS, Advanced Mobile Phone Service. This was the first high-tier system developed by Bell Labs. Nowadays, it has become obsolete. Second, GSM, Global System for Mobile Communication. This is a widely used high-tier system. It was developed by a very famous organization, CEPT. And two others listed over here are form of CDMA. AMPS. AMPS was discovered by Bell Labs in 1970. AMPS was used first for military purpose, and after becoming a hit, it was launched in USA commercially first. It works on the principle of FDMA. Frequency reuse concept was first patented for the use of AMPS. It is because of frequency reuse that AMPS is categorized under high-tier PCS system. Therefore, frequency reuse is a characteristic feature of high-tier PCS system. AMPS uses 50 channels per cell, and these 50 channels are reused in another cell by the virtue of frequency reuse. GSM. It is another type of high-tier PCS system. It was developed by an US organization, CEPT, which is famous for its contribution to innovation in technology. GSM combines the features of TDMA and CDMA, that is time division multiplexing and code division multiplexing. It is better than AMPS because GSM inherits all the properties of AMPS and at the same time uses the concept of frequency reuse, that is frequency management is done in a far more better way. GSM is actually advanced form of AMPS and therefore it has replaced AMPS nowadays. Cordless telephone. Cordless telephone is an example of low-tier PCS system. Cordless telephone cannot be defined without its characteristic. Some of it are mentioned over here. Low mobility, that is speed and range is low. Low power consumption. Since mobility is low, therefore power consumed is also low. Two-way tetherless voice communication, that is two-way, full-way, duplex communication is possible via cordless telephones. Circuit quality is very high and also the equipment cost is low. The last slide is a comparison between different types of PCS. We have categorized PCS on basis of 8 parameters. High-tier cellular, low-tier PCS and cordless are differentiated over here on basis of 8 parameters. Some of the important parameters are cell size, user speed and coverage area.
Implementation problems. After implementation of PCS system, two main issues were raised. First, high user density, that is, utilization of channel and frequency as number of users were increasing. Second, continuous communication, how continuous communication should be made possible without any interruption. Hence came the concept of frequency reuse, mobile cell, handoff, and roaming. Mobile cell. A cellular system is a radio network distributed over land area called cells. Each cell has at least one fixed location transceiver known as cell site or base station. Each cell uses different set of frequencies from neighboring cells to avoid interference and provide bandwidth. When joined together, these cells provide radio coverage over a wide geographical area. This enables a large number of transceivers to communicate with each other. More the number of cells, more simultaneous calls possible. Hence, the area with low density requires large cells and with high density requires smaller cells. Frequency reuse. The goal of every mobile service provider is to manage as many as simultaneous calls as possible. Hence came the concept of frequency reuse. For example, A person talking on mobile phone needs only allocated frequency of cell. Thus, somebody else on other end can use same frequency in a different cell. This concept of multiple users using same frequency at same time for communication is called frequency reuse. For frequency reuse to work properly, sufficient amount of power should be transmitted by base station to cell side. If too much of power is transmitted, it may reach to unintended cell sites which others may be using at same frequency. This limitation of transmitted power is however also an advantage because cellular phones have longer battery life. Handoff and roaming. To maintain communication between two parties in the presence of mobility, handoff is required. For example, when a mobile user is engaged in a conversation, the mobile station is connected to the base station via radio link. If mobile user moves to the coverage area of another base station, the radio link to the old base station is eventually disconnected and the radio link with the new base station is established. This switching of an ongoing communication from one cell frequency to different cell frequency is called handoff, whereas roaming is when user moves from one PCS system to another PCS system. Summarizing our topic, I would like to highlight that PCS was a revolution in the field of communication, thus transforming our lives. As discussed earlier, PCS has wide application in our day-to-day activities. PCS forms a base for implementation of various technologies, thus proved to be problem-free solution to real-world scenarios.